Hey everybody, we're going to be talking about the atom for the first half of this next unit. So let's get started. So I know that you know that an atom is really small, but it's hard to really wrap our minds around how small it is. So here's three different examples to help kind of get your mind around how really small we're talking about. Now, since an atom is so small and we can't really comprehend that, like we can't show you an atom, we have to depend on models of atoms. And we know about the insides of atoms, what's in the interior, from firing particles at atoms and seeing what happens as a result of that. So what we're getting ready to talk about now is really the results of our experiments with atoms. So what is an atom? Like it says here, an atom is the smallest part of an element that still retains the identity of an element. So, good question. What do we mean by the identity of an element? When we talk about the identity of an element, we're talking about its atomic number. That's how we identify what element an atom belongs to. Now, when you look at the periodic table, in each little box the element resides, and there is a symbol for the element, like here N is nitrogen, and we see a whole number. The whole number is the atomic number, and that tells us how many protons there are in the nucleus of the atom. That's how we identify an atom. So here you can kind of see carbon, there's a 6 there. That means carbon is identified as having 6 protons in its nucleus. Here's oxygen. There's an 8. That means an oxygen atom is identified by having 8 protons in its nucleus. It has an atomic number of 8. Now, when you look at a periodic table, that whole number may not always be in the same spot. So, for example, look at this one. Notice the whole number is down here. That's the atomic number. There will be 2 numbers. One will be a whole number, that's the atomic. The other will be a decimal, that's the atomic mass. We're looking for the whole number, the atomic number, which is the number of protons, and that's how we identify the element. So we just said that the protons are in the nucleus. What is the nucleus of the atom? It's an extremely dense central part of the atom. The rest of the atom is surrounded by electrons. The nucleus is practically the whole mass of the atom. The electrons don't contribute much to the atom's mass. It'd be like if you got a haircut and how much that would change your mass. That's kind of like what would happen if an atom lost some electrons. What's in the nucleus? There's protons, which are positively charged, and there are neutrons, which have no charge. And they're about the same size. Together, the protons and the neutrons are called nucleons. Kind of like we who live here in Chattanooga are called Chattanoogans. That's where the protons and neutrons reside, in the nucleus. So you may have been thinking, hey, wait a minute now. If the neutrons have no charge, but protons are positively charged, I know that like charges repel. What's holding this nucleus together? How come the protons aren't repelling each other and pushing each other apart? The reason for that is that the nucleus is holding those particles together by something called the strong nuclear force. The strong nuclear force is one of the strongest known forces in the universe, but here's the thing, it only works over really short distances. Notice that we're talking on a scale here of femtometers. Femto is it's a metric prefix. That means 10 to the negative 15th. And so that's even smaller than pico, nano, all those. That's what we talk about when we're on the atomic scale. So there's also a mass number in addition to the atomic number. What's the mass number? That's the sum of the protons and neutrons. So right here in this picture we have something called a nuclear symbol. Notice it has the symbol of the element. Notice it has the atomic number down here. What we see here in the upper left is the mass number, and that's the sum of the protons and the neutrons. And if the atomic number is the protons, obviously the difference between the two is the number of neutrons. So this sodium, 23 minus 11, would have 12 neutrons. Something else that you may notice is a charge, which is written to the upper right, and we'll talk more about that later. So like we said, the picture we were just looking at is a nuclear symbol. What does a nuclear symbol contain? Well, it contains a symbol of the element, here symbolized by X. It contains the atomic number written as a subscript to the lower left. That's the number of protons. And it's got a mass number, which is the number of protons plus the number of neutrons. So how would we write that from an element off the periodic table? Well, here's gold. We start off by writing the symbol AU. Notice there are two numbers here, a whole number and a decimal number. The whole number is the atomic number, and that goes down here, 79. Here, this atomic mass, to make that the mass number, we round it off to the nearest whole number. So that number would round off to 197. And to figure out the number of neutrons, we would just subtract those two. Over here, we have iron. We see that the atomic number is 26, that's the whole number. This number down here at 55.845 is, when we round it off, it'll be the mass number, 56. So you can see here that this atom of iron has 26 protons and 30 neutrons. I also want to point out that both of these atoms are neutral. Notice there's nothing written up here in this upper right area. We'll talk more about charge in just a minute. So you may be wondering, hey, when I look on the periodic table, like if I look at sodium, yeah, I see the symbol, yeah, I see a whole number, but I see a decimal number too. What's up with that decimal number? Same thing down here. Here's nitrogen, the symbol for it. Here's the atomic number. What's up with this decimal number? Well, that decimal number is called the atomic mass. Now, the reason it's not a whole number is that it represents the average of all the different types of atoms of nitrogen. What we mean by that we'll talk about in a second. But when we write a nuclear symbol, like for nitrogen, there's the symbol for N, there's 7 for the atomic number. We simply round off that atomic mass to the nearest whole number. For sodium up here, the nuclear symbol is Na. 11 would be the atomic number. Round this number off, 23, that's the mass number. However, that still doesn't explain why is the atomic mass written as a decimal. The reason the atomic mass is written as a decimal is because of the existence of isotopes. So let's look at the element lithium, for example. How do we know it's lithium? It has 3 protons. No other atom has 3 protons except lithium. But there's a difference here. In this first atom of lithium, there are 3 protons, which we would expect since it's lithium, but there are 3 neutrons, giving it a mass number of 6. In the second example of lithium, sure enough, there are 3 protons, just as we would expect from lithium. But there are 4 neutrons this time, which affect the mass number, or the mass of the atom. And then in this last example, we can see that there are 5 neutrons. It's still lithium, however. So an isotope is an atom of the same element that has a different number of neutrons, and that in turn affects the mass number. And so when we see an atom that has a decimal, it's taken into account the average of the mass numbers. We'll talk more about how that works later. So we talked a few minutes ago about this idea of an atom having a charge. An atom that has a charge is called an ion. And ions can be either positive, they can be negative. So what it depends on is whether or not an atom has lost electrons or gained them. Normally, atoms have the same number of protons as they do electrons. That makes the atoms negative. But if an atom loses or gains an electron, then it has a charge, and we call it an ion. So, for example, let's say an atom has 5 protons and it has 5 electrons. As you can see, there's the same number of pluses as there are minuses. It's neutral. But what if it has 5 protons and only 4 electrons? Well, then the atom has a net charge of +1. By the same token, if we have, let's say, if we have 5 protons and we have 5 electrons, and then we lose one of the electrons, so we only have 4, then this atom has a plus charge. One thing I want to emphasize, an atom only becomes an ion by gaining or losing electrons. The nucleus does not change. So here, in this example, in this picture, we've got an atom that has 3 protons and 3 electrons. It's neutral. Over here, though, it has 3 protons and only 2 electrons. It has one more positive than negative, so this atom would be positive, and we call it a positive ion. So positive ions, which are created by an atom losing electrons, are called cations. Maybe you can remember they're positive because the word cation has a T in it, which kind of looks like a plus sign. Negative ions are called anions. So take a look here. Here's the nuclear symbol for sodium. We can tell it has 11 protons because of the atomic number. 23 minus 11 means it has 12 neutrons. Now, since it seems to be neutral because there's no charge right here, we assume then it has the same number of electrons as protons, 11. But let's say we lost one of these electrons and we only had 10. Then we would have one more proton than electron, and we would have a cation, sodium cation. Over here, fluorine, we have 9 protons. We can tell because of the atomic number. 19 minus 9 means we have 10 neutrons. And since there's nothing here to indicate charge, we can assume then that it has 9 electrons. However, what if it gains an electron? Then it would have 10. And it would have one more electron than it does proton, and that would give it a negative charge, and we would then call it an anion. All right, everybody, that's it. Thank you for watching.